Bismillahirrahmanirrahim. Assalamu alaikum dear viewers. I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about the next part of Nomenclature of Heterocycles, in which we will study that how to name the heterocycles when they contain two or more similar or different heteroatoms. So, if a heterocycle contains two or more similar heteroatoms, then these heteroatoms are indicated by using an appropriate prefix, for example, that is di, tri, tetra and penta for 2, 3, 4 and 5 heteroatoms. So here there are some examples for the practice. We start from this one, that is a 5-membered heterocycle containing two similar atoms that are nitrogen atoms. So here there is another rule that if the both heteroatoms are similar, then we will start the numbering from that heteroatom which is saturated one. So in this case, both of these nitrogens, this nitrogen is the saturated one, so it would be given number 1, and this nitrogen is doubly bonded to this carbon atom, and so that means it is unsaturated in nature. So we will start the numbering from this and then we will move towards that direction which is closer to the other heteroatoms. So here that is 1, 2 and 3. But if we move along this side, then 1, 2, 3 and 4. So along this side, this nitrogen comes at 4th position, so we will not move towards that direction. So rather we will prefer this direction. So here that is 1, 3 diazole, because this is the 5-membered unsaturated system having nitrogen atom. So that is azole. So at 1, 3 diazole. Similarly here, as it contains 3 nitrogen atoms and it is 5-membered unsaturated heterocycle, so these 2 nitrogens are unsaturated ones, but this nitrogen is saturated one, so we will prefer this one and it would be given number 1. Then we will move towards that direction which is closer to the other heteroatom, that is 2, and if we move towards that direction, then it is at 3 position, and so we will prefer this direction, that is 3 and 4. So here that is 1, 2, 4. As there are 3 nitrogen atoms, so we will use the prefix tri, that is, and azole is the parent name for this type of heterocycle containing 1 nitrogen, because other nitrogens have been indicated by these prefix. So its complete name would be 1, 2, 4 triazole. And in this case, this is the 6-membered unsaturated system containing nitrogen atoms. And here there is no nitrogen in the saturated form. So we may start the numbering from either nitrogen, either this one or this one. So we start from this 1, 2, 3, 4, 5 and 6. So the nitrogens are at 1, 3 and 5 positions. Here these are the 1, 3, 5 tri. So this is the 6-membered heterocycle containing nitrogen atom, and the parent name for such a system is azine. So the complete name would become 1, 3, 5 triazine. So in these examples, the rule becomes if more than one heteroatom occurs in the heterocycle. For example, here that is the oxygen and nitrogen, here that is the sulfur and nitrogen, and here this one contains 3 heterocycles. So in such cases, if more than one heteroatom occurs in the ring, then the heterocycle is named by combining an appropriate prefix with the ending in order of their preference. As the order of the preference is, we will give the preference to the oxygen, then the sulfur, and then to the nitrogen. So based on this preference order, we may write down the names of these compounds like, so here we will give the preference to oxygen, so this would become as a prefix, that is oxa. And here now see that this is the 3-membered saturated system containing nitrogen, and in that case its parent name is aziridine. So the last letter of the prefix is omitted and then it is combined with the parent name. So the complete name becomes like this, that is oxaziridine, that is oxaziridine. And then for this is the 5-membered system, and here according to this preference order the sulfur would be given priority, so its name would become as a prefix, that is thia, and as the last letter of the prefix would be omitted, so it would become thi, and the 5-membered unsaturated heterocycle with containing nitrogen is named as azole, so here it would be azole. So the complete name would become thiazole, but we also have to mention the positions of these heteroatoms. Still, based on this preference order, this oxygen would be given priority, so it would be given number 1 position and it would be given number 2. So here it would become 1, 2 oxaziridine, and here it would be, this sulfur would be given number 1. Along this side the nitrogen is closer, so it would be at 3 positions, so it would be 1, 3 thiazole. And in this system it contains a 6-membered heterocycle containing nitrogen, and that is the unsaturated system. So in this case the parent name for this would become azine, and there are 2 sulfur, so it would be dithia. And at which positions there are 2 sulfur atoms, that are, okay, here we have to decide that which sulfur atom would be given priority. Here we will give the priority to that heteroatom which is closer to the other heteroatom. So here it would be 1, 2, 3 and 4. If we move along that direction, then 1, 2, 3, 4. So at 1 and 4th position the 2 substituent would be, but here in this case the closer substituent are at 1 and 2 position, so this numbering would be preferred. So it is at 1, 4, that is for dithia, and then that is 2 dash for azine, azine's nitrogen. So here you see that we will not write down these numbers according to their order, rather depending on the position of the same heteroatom these numbers would be given here. So the 1, 4 means that is for dithia, and 2 for for azine. So its complete name would become 1,4,2-dithiazine. And here the nitrogen would be given 1, as along both of these directions the nitrogen or the second heteroatom is at equal position. So we start from these 3 and 4. No doubt this nitrogen is saturated one, but we have to follow this preference order. So according to 8, its name would be 1,4-oxazine, as this is the 6-membered heterocycle containing nitrogen in the form of unsaturated heterocycle. So its name is azine, and the 1 shows position of the oxa group and 4 shows the nitrogen of the azine. So in this case, in this way, its complete name would become 1,4-oxazine. And in this case, here the oxygen would be given priority, this one, and then the other heteroatom would be given priority, not this substituent. So we will move towards that direction, towards the other heteroatom, that is 1, 2, 3 and 4 and 5. So this is the methyl substituent and this is the chloro. So we have to write down these two substituents alphabetically. But first we have to follow this order. So according to 8, this becomes 3-chloro, 5-methyl. Now the position of these heteroatoms has been to specify, that is 1, 2 and 4 oxadiazole. So 1, 2, 4, 1 shows the position of the oxa group, 2, 4 shows position of these diazoles, nitrogens. So in this way, its complete name would become 3-chloro, that here 3-chloro, 5-methyl, 1, 2, 4 oxadiazole. Hence, priority of the heteroatoms comes in this order, as the oxygen is given the highest priority, then the sulfur, then the priority becomes decreasing, oxygen, sulfur, then selenium. The priority would decrease from this order, from oxygen to selenium, but it would increase from selenium to oxygen. And then the priority would decrease to the previous group, or as these elements belong to the 6th group, and the priority would decrease to the 5th group elements, and then to the 4th group element, and then to the 3rd group elements. So in this way, the priority order would decrease in the case of nitrogen, then phosphorus. So the priority would be decreasing from nitrogen to phosphorus, and then it would increase from phosphorus to nitrogen, but then it would decrease to carbon, and then it would become to boron, and the lowest priority would be given to the boron as compared to the carbon, then to nitrogen and phosphorus, and then to this one. Here it shows the highest priority in the case of oxygen. If these heteroatoms come in a heterocycle, any of these, then you would prefer the oxygen over sulfur and sulfur over selenium, then the nitrogen over phosphorus, and then over carbon, and then over boron. So in this way, their priority becomes decreasing along this direction, along this direction, along this one, and then this one. Its priority order decreases from oxygen to the down the group and to the first group elements, that is from oxygen to nitrogen, then to carbon, then to boron. So in this way, it also decreases from the other groups that are placed at the right hand corner of the periodic table, that is 1A group elements, second A, third A, fourth A, and fifth A group elements. So its priority order would be the highest in the case of oxygen, and as it decreases, and then it becomes lowest for boron. So there is one more example, as we consider the nitrogen and sulfur as the heteroatoms in a 5-membered saturated ring. So on the basis of priority order, we would give sulfur the number 1 position. So as the rule is, the ring is numbered from the atom of preference in such a way so as to give the smallest possible number to the other heteroatom, that is nitrogen in this case, and the position of this substituent would be ignored because we cannot move along this direction, that is closer to this substituent, but in that case this would be ignored, but we will move towards that direction that is closer to the other heteroatom in the ring based on the priority order. So its IUPAC name would be 4-methyl 1,3-thiazole. That is 4-methyl 1,3-thiazole. As at the 4th position there is a methyl group, and at one position there is a thia group, that is sulfur, and azole as a group is at 3rd position. So in this way, these were some examples of the heterocycles that we have named. So thank you very much for watching the video, and please subscribe my channel and press bell icon, and also let me know in the comment section that how much this video is helpful for you. So thank you very much. Allah Hafiz.